When you tell people that 1 over 7 is your favorite decimal expansion, at least up to like, 10, because that's the only ones I have memorized, people kind of look at you like you're a bit weird, and I don't know why. It's a mystery to me. But here it is. 1 over 7 is 0.142857, repeating for forever and ever. And I could make a whole nother video on why this is fascinating because of this 14 and then 28. There seems to be some doubling, shenaniganery going on. But what I want to look at is what's called a full Repton prime. And 7 is the first in our numbers that behaves this way. If we look at 2 over 7, I don't need a calculator, but you could use a calculator to verify what I'm doing. You get 285714. Now, the reason I didn't need a calculator is not because I'm a genius, although maybe that is true. Uh, sorry. Um, but what I hope you can tell is what the 6 digits I wrote for 2 over 7 and the 6 I wrote for 1 over 7 are exactly the same. In fact, the 28 just seems to have shifted over and then everything else behind it followed. And what this happens is entirely like predictable and done for all of the fractions with 7 as a denominator, at least proper fractions, I should say. So 3 over 7, it's the same 6 and the same 6 and same 6 and then all the way down. What's also interesting and kind of cool to point out is notice how many decimals there are. There's 6, which is exactly the prime 7 minus 1. This is a very like fun kind of party trick. If someone says they're 5/7 of the way through something, then you can be like, ooh, 5 times 14 is 7. So they're 71.4285% of the way through. And everyone's like, whoa, that guy's so smart. But yeah, what's the coolest thing to me about this is this happens because of how 7 behaves with 10, which is no coincidence because we write and we use decimal base 10. So this is not an inherent property of 7, but instead how 7 behaves under the base we choose to use in modern day math. Yeah, anyway,